Assalamu alaikum and welcome to our channel. I am Dr. Ahmad Ismail. Today we will talk about the calculation of free energy landscape. Free energy landscape, also known as FEL, is an important tool which can be used to determine the behavior of molecule and biomolecule over the time. It is based on the calculation of principal component. Once we calculate the PC1 and PC2, and then we'll calculate the free energy landscape. For this we will use the Python package and we will be using the PCA from the Gromacs. We have performed molecular dynamic simulation using the Gromacs tool. After we will perform PCA analysis and then we will perform free energy landscape calculation. So let's start. The Python program which we are going to use in this tutorial is Bioinformatics Debug. This is the complete link of the tutorial and it is based on the principal component and it utilizes some scripts. The scripts are available on the GitHub. You can download the script from here. We will also provide the link of the working file as well as the script in our video description. You can go to the description section of our video and download all the working file and scripts which we have used and modified in this particular tutorial. For the detail, you can read all this document. This is the GitHub link for this tutorial. You can download this Python script which will be used in later program. For this tutorial, I have prepared a folder with the name Gromacs and placed it in the desktop. For this tutorial we need following these three files. Let me show you. The first file is md_0_1.xtc file. This is the xtc file which was generated after the molecular dynamic simulation, and the other one is the same tpr file and the other one is the grow file. The grow file is the coordinate file and these are the trajectory and these are the topology file. These three files will be needed for the next step. If you are interested that how we can perform molecular dynamic simulation of ligand and protein, we have a complete list of Gromacs on our YouTube channel which cover all the topic of the Gromacs. The link is provided in the description section. The other two files are, these are the Python script file which we have downloaded from this GitHub server, and the rest one is this is Python script. This is also present on this link over here, but this link is for the Python 2.7. as we know that for the later version Python 2.7 is obsolete now, so we have changed the script which can be adjusted and which can be run using the Python 3. So we have modified this script according to the Python 3, and this demo also considered be working perfectly fine with the Python 3 version. The link for all these files will be provided in the description section of the video. We will provide the link. You can simply go to the link and download all these files. For this tutorial we will be using Ubuntu as WSL system on Windows. In this tutorial we are using Ubuntu 24. Now first of all we need to update our Ubuntu. For updating, this is the command update and upgrade. You can run this command once in a day. It will ask you a password, type the password and it will update. We are suppose that you have already installed the Gromacs and you have set up the Ubuntu. If not, you can refer to our link for installation of Ubuntu. The complete step-by-step guide is provided along with the downloading commands and installation command. Once you have installed, then we need to source the folder. For sourcing the folder, my folder is at the desktop. Let me explain you briefly. This is my folder is you can click on the address bar, copy this address bar, go to this one, and you need to make changes. You need to type cd space / mnt mean mounting, then / make the C small, remove the colon and remove all the backward slashes and change into forward slashes. Change all the backward slashes to the forward slash. This will become your path. This is what I did in the previous command and type enter. Now you are in the folder in which you are working. Type ls, it will list all the files which are already present in this environment, in this folder, sorry. Next step is sourcing the Gromacs. For sourcing Gromacs, use this command, copy this command and go to Ubuntu terminal and paste it. After sourcing it, we have created an environment. For environment creation, this is also explained in the previous video. Simply copy this command and paste it. I think there is an error in the command. Oh yes, this backward slash is extra, this slash was extra, remove it and press enter. Now the command is done. Now we are in our environment, which is Gromacs _ environment, and there was error in the command. Let me correct in the main file. We don't need this / After activating the command, we are going to perform the PCA analysis. Before performing the PCA analysis, we need to center our trajectories. As I told you earlier, if we look into our folder, this is trajectory file, this is topology file, and this is coordinate file. From this file, we need to center the trajectory, then we remove it extra periodic boundaries, then we will go for the PCA analysis. So this is the command in which we are going to center all the trajectory. Copy this command, go to Ubuntu terminal and paste it and press enter. It will ask you here, you can choose the system or you can choose the protein. Here I am going to choose the system, which contain both protein and non-protein parts. Again change, I am going to choose the system, type 0 and press enter. All the trajectories has been centered. After trajectory has been centered, we have to remove periodic boundaries. For periodic boundaries removal, we will choose this command, copy this command, go to Ubuntu terminal, type the command, press enter. Here I am going to choose the protein. For protein, type 1 and press enter. Periodic boundaries has been removed. After removing the periodic boundaries, we are going to calculate eigenvectors and eigenvalues for the PCA analysis. For this one, we are going to use gmx cover command, and in which we will use the trajectory without periodic boundaries, and it will generate eigenvectors and eigenvalues. Copy this command, go to Ubuntu terminal and paste it. It will ask you what you want to do. Here we are going to use number 4. Number 4 is our backbone. Type 4 and press enter. Again type 4 and press enter. After completing this job, we are going to calculate the PC1 and PC2. For PC1 eigenvalues, we are going to generate PC1. For generating PC1, use this command, copy this command, go to Ubuntu terminal, type the command and press enter. Here again choose number 4. Number 4 is our backbone. Again choose number 4. Number 4 is backbone and type 4 and press enter. PC1 has been generated. Now we will generate the PC2. For PC2 again we are going to use this command. The second one, type the command, press enter. Again type 4 and press enter. Type 4, press enter, and our PC2 has been generated. After generating PC1 and PC2, we are going to combine PC1 and PC2 in a single file. For generating into single file, XVG file, we are going to use this command. Copy this command, go to Ubuntu terminal, type the command or paste the command and press enter. Now PC1 and PC2 has been generated in a combined file. You can have a look in your folder. You can see here, this is PC1 and this is PC2, and this is the combined file with PC1 and PC2. You can look into the content using any notepad. I use Notepad++ because it is more handy to use. This is the component of PC1 and this is the component of PC2, and then this is the combined component. You can see here the values are multiple. In PC1 there are 2 columns, where here are 3 columns, which means PC1 and PC2 component have been combined. Now we have combined the PC1 and PC2. The next step is generation of Gibbs free energy. We will generate the Gibbs free energy using Gromacs sham command and the file we will use is the combined PC1 and PC2. So copy this command, go to Ubuntu terminal, type the command and press enter. The FES.xpm has been generated. Go to the folder. You can see the file has been generated. This is your file. You can open into any notepad and see the content. The content has been generated. After generating the Gibbs free energy, convert it into dot file. To convert into dot file, we will need xpm to text.py. If you remember, we have placed this file at the start in the folder. This is xm to text.py. We have modified this file according to the Python 3. The file present on the original server over here is constructed for Python 2.7. If you are interested in 2.7, you can download this file and use it. But as I told you earlier, we are using the Python 3 version, so we have modified this file according to the Python 3. This file will be available in the video description section for downloading. You can simply download and place the folder and run your command. It is simple. Now we are going to generate the FEL.file. To generate this file, copy this command, go to Ubuntu terminal, type and paste the command and press enter. You can see FEL.file has been generated. You can open in the notepad and you can see all the values has been added in this file. This is the file which will be used to generate the graph. Simply I will close this file. There is one other command. If you want to generate the conformational analysis to see the 3D structure of new file with no PBC, you can run this command in Ubuntu. This is additional step, and choose number 4 as a backbone and this file will be generated. This is the file is generated. You can view it into the Discovery Studio or you can use it into the PyMol. You can see the structure, that how without boundaries, no periodic boundaries, how the protein is look like. So this is the protein which is look like after no PBC. This is just an additional step. Now our work in the Ubuntu has been completed. The next step is to use this FEL.dot file. You can open this file with the Excel, or you can make graph using origin or some other values, or you can use the Python script to create the graph. In the next part, we will explain how you can use the Python script to create the graph. For this, you will need Jupyter or any other Python script code. I prefer Anaconda Navigator. Anaconda Navigator contains the Jupyter Colab and Jupyter Lab and Jupyter Notebook. The Jupyter Notebook is very simple and desktop version to use different kind of Python script. If you are interested that how to install Anaconda, we have prepared a separate video for the downloading and installation and running of Python and Anaconda and Jupyter Lab. The link for the tutorial is provided in the video description section. This is our Anaconda Navigator. Here you can find different softwares. This is Jupyter Lab and this is Jupyter Notebook. I am going to launch the Jupyter Notebook. It will automatically open in your browser. It will appear like this one. Here you can access your folder. As on my desktop, I have placed the folder of GMX. In GMX, if you remember, I have placed downloaded two files, FEL time frame extractor case 1 and extractor case 2. Let me show you. These were the two files which I placed at the start when I start the tutorial. So these two files are already present in this folder. I am going to use the first file. When you click on it, it will open as a new window. This is the new window, and this is case 1, generating free energy landscape FEL and extracting conformation and minimum region using Gromacs. This file let me tell you one important point, that all your Gromacs files are present in this folder, your Python script is present in this folder, and your FEL files are also present in this folder. When you run this command from this folder, like you say, we have accessed the desktop. From the desktop we access our GMX folder, and from GMX we have opened this file. When we open from this location, it will automatically access all the files present in the folder, and if you follow this route, you will see no problem at all. If your file is in a different folder and you are accessing the Python from the different source, it will not make a correlation and you will get an error. So what you next to do, just simply click on this box. You will see a blue arrow over here and click on the play button. It will show the star sometime and star will appear. It means everything is fine. Then it will move to the next. Place your cursor over here and then click play. Then on the next, place your cursor over here and next. Now it is running. Minimum points, point 1, point X, point Y. It means it's running. When it's running, now it has generated your graph for free energy landscape. This is the graph for your free energy landscape. This is your PC1, this is your PC2, and this is your free Gibbs energy. It will download the figure and figure will be showed completely. It's just a resolution error, nothing else. This is the graph which we are interested. Then extracting time frame. If you are interested in some time frame, you can run this command, and if you are avoiding or you are going to specify any frame or array, you can run this command. After running this command, your job is completed. Now we can go back to our folder. You can see some more files are being generated there. FES, entropy file has been generated, enthalpy file has been generated, energy file has been generated, bindx file has been generated, FL dot file is already present, and this is your graph, which is downloaded in the PNG form. You can use it for your, you can see here the graph is complete now. Gibbs free energy landscape, PC1 and PC2, and then this is your Python script. You can also open this file in Excel and you can make graph as per your need and per your requirement. So let's have a quick overview about this file. This is going to import NumPy and other plotting data. The second column shows the load the data. It is loading the data. The name is FEL.dat. If you have changed the name, then also change name over here, and it will extract the coordinate x axis, y axis and z axis. X is 0, y is 1 and z is 2. The third column is your 3D plot is generated. This one, if you want to change the color, the sequence, you can make modification in that. This is the figure size, 10:8. You can change the figure size. This is the projection. You can make 3D or 2D and so on. This is the plot for free energy. It will use x, y and z. Edge color is none, and then x axis label is PC1, y label is PC2, z label is Gibbs free energy, and the title is free energy landscape. You can change the titles and labels according to your need. Then these are the points for the original database, which is z axis, x axis, y axis and z axis. This is the minima region on the plot. This is the minima point shown, that minimum length and maxima. Then how you can print out the points and plot minima. You want to see the ligand and how you want to save the file. This is the name of the file. You can also change the name of the file and you can show the plot. These are the main settings for your graph. You can change the graph according to your need. These are the minima load points. It will load the point from PC1 and PC2 XRG and it read the frames. This figure is used to store the PC1 and PC2 and time frame. So this is the case 1. In the same way, this is the case 2. In the same way, you can run one by one each cell of the case 2 for free energy landscape. With minor modification, you will get the different kind of graph, a slightly different graph according to your need. So this is all about today. If you have any question, please type in the comment section. Please like and subscribe our channel for more video. Thank you so much for watching. Allah Hafiz.